Good day. Next, our topic is about projectile motion. So, for free fall and UAM, isang dimension lang ang ating kino-consider, either horizontal for UAM and vertical for free fall. Now, two dimensions na or two directions of motion ang ating i-consider. So, for the definition, projectile motion is the motion of an object or projectile traveling into the air. The object thrown will follow a parabolic path called trajectory. The path was affected by air resistance and the pull force acting is the gravity. Its value is 9.8 meters per second squared sa metric and 32.2 feet per second squared sa English. For the types, yung type 1 and 2, napag-aralan na natin siya sa free fall. Yung object dropped from rest and object thrown upward or vertical. So for that type 3, dito tayo magpo-focus sa object thrown at an angle to the horizontal projection. So from this diagram, for example, so this is our horizontal ground. So let's say this is the horizontal plane parallel to our ground. But yung girl, yung ball, tinrow niya at an angle, at a certain angle. So, hindi siya horizontal tinrow nung girl. So, magkakaroon tayo ng projectile motion. Therefore, due to gravity and air resistance, mag-change yung direction ng ball, and then as it changes, it will go back or drop until it falls back to the ground. So to give you a diagram here, we have first the initial velocity, kung gaano kabilis hinagis yung isang object. And then this line shows the projectile motion or the trajectory. This h is the maximum height reached by the object. That is in terms of vertical motion. And this one naman is blue. The blue one is the pertains to the range. This is the maximum displacement traveled in terms of horizontal motion. And then for the theta, this one is the angle of projection, projectile motion or the trajectory. And since ang ating initial velocity ay tinrow at an angle, magkakaroon tayo ng dalawang component. Those are the x component and the y component. So to explain further, okay, let's erase. So to explain further, here are the components of projectile motion. So first, we have, syempre, the velocity, yung speed, in meters per second or feet per second. We have the angle of projection or the trajectory in degree, represented by the symbol theta. We have the horizontal distance traveled, which is the x, and the vertical distance reached, which is the y. And then we have the range, the maximum horizontal distance traveled, represented by big letter R, and maximum vertical distance reached, represented by letter H, and time of flight, seconds, which is represented by small letter t. So, small letter t dapat ito. So, to further explain paano naging ganito ang pagkuha ng x and y component, so remember dun sa ating scalar and vector quantities, 'di ba, nagkakaroon tayo ng change of direction, hindi naman laging vertical or horizontal lang. So, if ever na ang isang magnitude ay ang direction niya is at a certain angle from the horizontal plane, magkakaroon talaga tayo ng dalawang component. So, let us remember these terms. SOHCAHTOA. So means the sign of the opposite of the hypotenuse. So para makuha natin yung y component, let us again recall right triangle. Okay, this is a right triangle, right? So this is the hypotenuse. Sabi, para makuha daw natin yung y component, ang gagamitin natin is the sign of the angle. Kasi sabi, sign of the opposite of the hypotenuse. So, ano ang opposite niya again? This one. And this side is equal to this side. So that will be our y component. And para makuha siya, ang gagamitin ay sine of the angle. And then, meaning cosine of the adjacent of hypotenuse. So adjacent is yung katabing side or yung remaining side sa ating right triangle. So ang gagamitin daw, cosine of the adjacent. So that will be velocity times cosine of the angle theta. And the TOA, this is sometimes used kapag ang given ay dalawang component and hahanapin mo yung angle of trajectory. Because tangent of an angle is equal to the opposite over adjacent. So ano ang opposite again? Sine. And then ang adjacent is cosine. So that will be tangent theta is equal to the sine of the velocity, y component of the velocity over the x component of the velocity. So now, explain naman natin kung ano yung nagiging component as the trajectory changes direction. So from the first point, kapag na-throw na natin yung object, again, magkakaroon siya ng direction at a certain angle. So ang kanyang components ay y and x. So for the x, again, cosine theta, and then for the y, sine theta. And then as it turns to its peak, this one is called the apex. So ang mangyayari, meron tayong x component, pero wala na tayong y component. Bakit? Kasi nga, maximum na to, hindi na at ang direction nito is horizontal na lang. So, ang mangyayari, magkakaroon tayo ng x component which is equal to velocity times cosine theta. And then, also, kung itatry din natin sa ating calculator, ang sine ng horizontal plane, for example, is 180 degrees is equal to 0. Kaya, 0 yung value ng ating y component. And then, as it changes direction, pababa. So, meron pa rin siyang certain angle. So, this angle is same or similar to this angle. So, this one. So, magiging parehas lang yan. And then, ang component niya, for the x, ganun pa rin, cosine theta. And then for the y naman, sine theta pa rin, pero negative na. Why? Kasi ito yung nag-determine ng direction. Ibig sabihin, pababa na yung kanyang y component. Now, let us introduce our formula. So we are considering two dimensions, the horizontal and vertical motion. For the horizontal motion, again, ang x component is equal to the velocity times cosine theta. That is the same for both initial and final velocity. Then for the displacement, we have the x component times time. So again, ang x component is velocity cosine theta times time. And then the range, the maximum distance traveled. Okay, this is the range again. The maximum distance traveled from the first point up to nalaglag na siya ulit is VO squared sine 2 theta over G. So, square of the initial velocity times sine of twice the angle over gravitational acceleration. Now, for the time, ang formula naman natin is 2VO sine theta over G. So, 2 times initial velocity sine theta over G. This time is the time of flight. So, from the first point na hanggang mag-fly na siya, marating niya yung apex or maximum height hanggang sa bumaba, ayun yung kanyang time of flight. Yung duration ng kanyang projectile motion. Now, for the vertical motion, again, yung y component natin, anong gagamitin? Sine theta. So, velocity times sine theta. And then, another formula for final velocity, we have Vy squared is equal to Voy squared minus 2Gy. So, final velocity y component squared is equal to the y component of the initial velocity squared minus 2gy. Again, yung y is a height reached at a certain period of time. Now, for the y, sinasabi nating height reached. So, mapapansin nyo, this is the same as the free fall. So, nagkaroon lang ng dagdag na subscript na y. Ibig sabihin kasi y component siya sa projectile motion. But, it is similar yung concept. So, we have y component of the initial velocity times time minus 1/2 gt squared. And also another formula, 1/2 sum of the initial velocity y component plus final velocity y component times time. Now for our h, so h is this one, the height from the apex to the ground. Ayan yung kanyang maximum height reached. So height will be equal to the square of the product of the initial velocity times sine theta over 2g. So kapag ito ay ating inilagay sa calculator, kapag tayo ay nag-calculate na, dapat yung buong quantity yung naka-square. Then for the time, same lang tayo ng formula. 2VO sine theta over g. Now, para mas maintindihan natin, let us apply this formula sa ating problems. For our sample problem number 1, a stone is thrown into the air at a 15 meter per second at an angle of 30 degrees. So, try nating i-simulate ang ating problem. So, meron tayong 15 meters per second, 30 degrees. For example, ang laman ng ating cannon ay pumpkin. So, let's try to simulate kung ano magiging itsura ng kanyang trajectory. Again, ang ating initial value, meron tayong, nagsimula tayo sa ground, so height natin is 0. This is the y sub o or the x sub o also. So we have angle of trajectory 30 degrees and the speed or velocity is 15 meters per second. Okay, so let us simulate. Okay, so that will be the trajectory of our object. So from the first point, tinrow siya at an angle, mararating niya yung apex, this one, the green dot. And then, it will change direction due to gravity. So, magfo-fall siya ulit sa ground up to this point, the final destination or the final distance reached by the object. So, anong hinahanap daw? We have for A, the height reached. For B, the time taken. So, meaning this is the time of flight in the whole travel. And see what is the range reached by the stone. So let's proceed to the solution. We have the given initial velocity 15 meters per second and our angle of trajectory theta is equal to 30 degrees. So we are going to find for height, time, and range. For height, so let us consider first our formula. Since ito ay simple problems lang, direct substitution kadalasan ang ginagawa sa projectile motion. So we have the formula for range, for height, and for time of flight. So for height, let's use this formula. We have square of initial velocity times sine theta over 2g. So direct substitution lang tayo. Our VO is 15 meters per second. Our theta is 30. And then our G is constant, 9.81 meters per second squared. Again, dapat yung whole quantity or whole product of these two ay yung naka-square. So, it will give us the answer of 2.87 meters. So, from our simulator, i-check natin kung tama. So, that is the height. Puntahan natin yung kanyang apex. Ayan. Sa apex natin, lumabas. So, tama yung sagot natin. 2.87 meters siya from the ground up to the apex. So, ayun yung kanyang maximum height reached. So, let's go back to our problem. So, tama ang answer natin. Let's go back to letter B. So, for the time of light, again, direct substitution lang tayo. So, better na sa ulado natin yung ating formula. So, we have 2 VO sine theta over G. So, direct substitution, 2 times 15 meters per second sine 30 degrees over constant 9.81 meters per second squared. So, ang lalabas na sagot as you calculate, 1.53 seconds. So, tingnan natin kung tama ang ating time of light. Again, ang time of light ay ang time from the first position up to the position kung saan siya bumagsak. So, the time is 1.53 seconds. Okay, so we have come up to the correct answer. For C, we are going to look for the range. So, meron tayong formula, direct substitution again. We have VO squared sine 2 theta times G. So, 15 meters per second squared sine ng 2 times 30 over 9.81. This is constant. So, we have 15 squared sine 60, 2 times 30, and then 9.81. That will give us 9.87 meters. So, roughly, yan, same ng sagot dito sa ating simulator, 19.86 meters. Okay, so proceed tayo sa problem 2. A ball is projected with initial velocity of 18 meters per second at an angle 25 degrees. What is the time of flight of the ball? So again, time. Meron tayong formula. So direct substitution tayo. Ang given initial velocity, 18 meters per second, and angle of trajectory is 25 degrees. So let us simulate 18 meters per second and 25. Tama, 25. Let us try to simulate. Okay. So, ayan. Zoom ko lang para makita natin ang buo. But to better see it. Ayan yung kanyang naging projectile motion. So, ang hinahanap daw is yung time of flight. So, ang formula natin, again, T is equal to 2 VO sine theta over G. Direct substitution tayo, magiging 2 times 18 meters per second sine ng 25 degrees over constant G, 9.81. Ang magiging sagot is 1.55 seconds. So, let's check sa ating simulator. Ang time of flight niya ay 1.55 seconds. Okay, so let's go to our last problem. What is the horizontal displacement of the object thrown into the air at a velocity of 30 meters per second with an angle of 25 degrees? So, again, meron tayong initial velocity, 30 meters per second. Meron tayong angle of trajectory, 28 degrees. Ang hinahanap ay ating displacement. So, let's find out kung ang displacement natin is within the projectile or it will be the same as our range. So, meron tayong formula for displacement. Again, it will be x component times time of flight. Pero ang time of flight, meron tayong formula na 2 VO sine theta over G. So, first, let us get or obtain our time of flight T. So, direct substitution. 2 VO sine theta. 2 times 30 meters per second times sine 28 over 9.81 rather is equal to 2.87 seconds. And then, para makapag-proceed tayo sa ating displacement, yung time na nakuha natin, sa-substitute lang natin dito sa formula. So we have velocity cosine theta times time. So that will be 30 meters per second cosine 28 times 2.87. And then that will give us 76.02 meters. So let's try to simulate kung para makita natin kung yung displacement na nakuha natin is within the projectile motion or ito na rin yung ating range. So we have 30 and then 28 degrees. 28. Let's try. Okay. Let's try to simulate. Ayun. So, hindi na siya nakita. Let's zoom out. Ayan. So, ito yung naging trajectory niya with a initial speed of 30 meters per second and 28 degrees for the angle of projection. Ganito kalayo yung marireach. So, now, let's see. From our time na 2.87 seconds, hanapin natin kung nasaan yung distance na ito. So, let's use our tracker. So, this point, 2 seconds na siya. At this point, 2.7. And at this point, 2.87. So, ibig sabihin pala, yung time of flight na nakuha natin is the whole time simula sa first position up to the final position. And syempre, yung range na nakuha natin is dapat approximately near this range because this is the horizontal displacement traveled. So, again, we obtained 76.02 and from the simulator, we have 76.06. So, malapit. Ibig sabihin pala, yung nakuha natin na distance traveled ay same sa range na naka-identify dito sa projectile motion na ito. So, that will be all for the concepts and sample problems about projectile motion. I hope you learned something and thank you for watching.